A field called information theory is a rigorous theoretical construct for information and was developed in the 1940s by Claude Shannon, an American electrical engineer and mathematician. In 1948, he published a paper titled A Mathematical Theory of Communication, which laid the foundation for information theory and ultimately much of the world of information technology that cybersecurity professionals worked in. Shannon proposed a mathematical definition of information as the amount of uncertainty reduction in a signal, which he discussed in terms of entropy, removed by a signal. To Shannon, the receiver of information could be described as having some prior state of uncertainty. That is, the receiver already knew something, and the new information merely removed some, not necessarily all, of the receiver's uncertainty. The receiver's prior state of knowledge or uncertainty can be used to compute such things as the limits to show how much information can be transmitted in a signal, and the minimal amount of signal to correct for noise, and to maximum the data compression possible. This uncertainty reduction point of view is what is critical to business. Major decisions made under a state of uncertainty, such as whether to approve large IT projects or new security controls, can be made better, even if just slightly, by reducing the uncertainty. Sometimes, even small uncertainty reductions can be worth millions of dollars. Risk management is about decision-making under uncertainty to mitigate the risks. Data is a digital information that based on empirical observations and provide quantifiable proof to reduce uncertainty. It helps taking the emotion and subjective judgment out of the decision-making process. Business organizations use data to build a more complete and accurate reflection on their attack surface, which is usually defined as the kind of total exposures of an information system. And it exposes value to untrusted sources. Data is a powerful tool in revealing changes, questioning long-held assumptions, and in facilitating communication between IT and business owners. Growing opportunities to collect and leverage digital information have led many business stakeholders to change how they make decisions, relying less on intuition and more on data. Data-driven security is a discipline that leverages the pervasive security data, applies statistical and machine learning analytic techniques, extracts actionable insights about cybersecurity risk models, such as threat, vulnerability, impact, and cost-benefit factors, to drive business decisions to assess, mitigate, and continuously evaluate risks. What constitutes security data is often in the eye of a beholder. Malware analysts gravitate toward processes, memory, and system binary dumps. Vulnerability researchers dissect new patch release activities. Network security professionals tap wired and wireless networks to see what secrets can be sifted through the packets as they made their way from node to node. Web logs and leak streams can be used to study the user behavior and detect malicious activities or intents in e-commerce sites. Email and messaging logs for spam or phishing detection. Video surveillance data, continuous multimodal sensory data, real-time transaction data are usually used for anomaly or intrusion detection, fraud detection, etc. This data can be gathered from many sources as we discussed earlier, from asset management, configuration and patch management, network and system management, security vulnerability and event management, identity and access management, IAM system, customer relationship management, CRM system, the incident response center, audit results, etc. Skills toward the journey of data-driven security, or in other words, data science for cybersecurity. This is a data science Venn diagram by Drew Conway. It is a simple visualization that depicts the essential skills toward data-driven security. In general, it needs to combine statistics and data analysis with visualization techniques, and then leverage the computing power and mixed with healthy dose of security domain knowledge. All of this begins not with products or tools, but with your own skills and abilities. Two underlying personality traits we see in many data scientists are curiosity and communication. It is only with that sense of wonder and curiosity that hours spent cleaning and preparing data are not just tolerable, but somehow exciting and worth every moment. The hacking skill. In the context of a security data scientist, it is meant to describe someone with a passion for using or perhaps abusing technology for benevolent goal. Be able to command computers through code, either via scripting language like Python or programming language like C. Knowing a wide variety of data formats and understanding how to slice, dice, and bend them to your will. Having the ability to think critically, logically, scientifically, as well as algorithmically. Being able to communicate your work through visualization, charts, tables, or verbal or written words. Math and statistic knowledge. In IT world, especially for InfoSec or cybersecurity professional, statistics is the weakest area. We'll scratch a surface on some common basic statistics concepts in this course. You don't need a PhD in statistics to be an effective security data scientist. It is important to have an understanding of the fundamentals of a statistical analysis and machine learning, even when you are part of a multidisciplinary team. The security domain expertise. When focusing on the topic of security domain expertise as it relates to data science, thought leaders, guru, and rock star need not apply. You just need to be solid practitioners with real-world experiences. Depending on your area of focus, since InfoSec and cybersecurity covers a broad range of topics, you may be applying your combined hacking skills, statistical knowledge, and expertise to the following tasks. Develop smart endpoint protecting system algorithms. Discover new ways to detect anomalous behavior in network data. Uncover patterns from vulnerability assessments to help determine why some systems fall out of compliance more than others. Provide meaningful and useful metrics for various components of your overall security program.